Thanks very much, Dave and Kathleen, for calling in. We'll get started very quickly. Hope we can get it done in 15 minutes. A brief introduction to where we got here, how we got here. ASHRAE, the ASHRAE 13 committee proposed a change to their guideline, and that guideline is here. And we had roughly a month or so to respond to it. David's going to get into the specific issues that he had questions about. Dave, were you able to find your markup?
Yes, I have it.
Okay, good. So we're going to probably switch over to Dave. So in any case, I look at these pretty much, and I have a number of other people, that are, Dave among them. We have about better part of 10 people here now watching these documents fairly closely. And Dave picked up one that was rather important. First of all, I should tell you a little bit something about David, and I'm going to let David speak in his own words about what he's done here at the University of Michigan. You want to introduce yourself first to Kathleen, David?
Sure, Kathleen. I've been with the university now going on 25 years, and basically I've been in charge of the building automation systems for 22 of those years. And once in a while I get asked to review this type of thing, and I had a few comments or changes that I think should be made to it, so I submitted those, and I guess we're going to maybe review them. There's not a lot of them, by the way. It's just a couple of things that I think need change, but things that we feel are important.
Let's see if I can get Dave's LinkedIn profile up here. Maybe it's not so easy to do this time. Kathleen, could you tell us a little bit about what you do for Haley Aldrich?
Sure. I am part of Haley Aldrich's geothermal group. We do geothermal ground source heating and cooling systems. We do both design, commissioning, operation, construction, field testing prior to installation, and also testing after installation. We do both open and closed systems, and wanting to know how our system fits into building automation systems and what people are doing in trends in building automation systems is important to us. Haley Aldrich in general is a firm that's got between 500 and 600 people. We have like 28 offices. It's based out of Boston, and we're traditionally people who deal with the underground. So we have geotechnical engineers, environmental engineers, geologists, hydrogeologists, etc. And we got into the geothermal ground source because our clients pulled us in since we were their ground people probably about a decade ago.
Okay. Well, thanks very much for that, Kathleen. Well, let's get into the specifics. I'm going to turn the screen over to David, and he'll explain what he did for a few minutes. And then ultimately, Dave, if you could, recapping what you were able to tell us about this building, which is one of the marquee buildings at the University of Michigan. It was courtesy of Stephen Ross, one of our benefactors. It is relatively new, and they did some different things here when they bought it, building automation systems. So, but before we recap what you did here, David, on the building automation system, I'm going to cut it over to you, and you can say yes to the screen as you as the presenter, and we can look at your words. Go ahead.
Okay. Can you see this okay?
Yep. I can.
Okay.
Okay.
I highlighted the changes I suggested in yellow, so there are a lot of changes here suggested that I didn't make a comment about, but let's take a look here. The first one was about their statement saying in a campus building, each building will have its own outdoor air sensor and occupancy schedule. And they're basically trying to allude to the idea that these are mostly standalone buildings, and the IT world doesn't have to be as concerned about moving data around because buildings are pretty much not communicating with each other very much, but in our case, that's certainly not the case. We rely on a master outside air station that we use to monitor conditions, that we have good control over, both the location for accuracy and the ability then to make sure that it stays maintained properly. And then that information is shared amongst the 140 buildings on campus. To put an outside air temperature and humidity sensor at each building, number one, it's very difficult to find locations in every building where we could get an accurate reading that either don't have problems with anything from being on top of a roof where you have a lot of thermal heat rising from the roof, to not having a good surface where we can mount the sensor that's aesthetically pleasing, and or just the general locations that we've tried in the past to get a good, accurate sensing. We found that it's not as easy as it would seem. Even just using the housings that are available, that you can set a sensor out into the sun and it's a solar shield. When they're new and they're nice and white and bright, they can work okay. But then as time goes by and dirt builds up on them, they start heating up when the sun's out and changes your sensing. And of course, when you're relying on this information as to whether or not you're going to start a chiller or not, you really don't want to bring on a chiller when the outside air temperature isn't as warm as the sun might make you think it is. So that's an energy component for us. But from a sheer locating these on various buildings, if we're able to find spots to mount these, wire conduit, hooking them up to the systems and so forth, we're talking total for us of over $500,000 to add sensors to every building. So that's certainly something that we don't think is necessary, and don't want this comment to become something that is a must follow down the road. So that was the comment about that.
Dave, how many sensors does the entire University of Michigan campus have now?
Well, total points on the system are over 200,000 points. We have sensors sometimes in every room, depending on if we have individual room control like we do there where you are right now at the Ross School of Business. But we have about 80,000 sensors.
Well, no, I should back up again. Just confirm or deny, J.W. Krantz had said that we have 2 outdoor air sensors, one at North Campus and one in Central Campus. Is that true?
Oh, yeah. If you're only talking about outside air sensors, we have one master location that we use for all of campus. We do have some sensors that in other locations that we could use as a backup, and just in looking at those and seeing how they compare, we found that they don't always read as accurately as we'd like them to. So we certainly wouldn't want to rely on something other than our main master outside air sensor, which has proven to be quite reliable and accurate.
Right. So when he had mentioned at the MIAPA conference, and this is during one of the after presentation Q&A, had mentioned that we rarely see 1 or 2 degree differences between the sensors along the 6-mile axis that really defines the footprint of the university in Ann Arbor, and that we have, 140 odd buildings there. You and I know that there's not a lot of difference in temperature between the Krause building and the chemistry building, a couple hundred yards apart. So to have to go and install a $5,000 piece of equipment that, as you mentioned, was subject to maintenance after time, and then will result in will result in errors that could conceivably turn on or turn off chillers in a less optimal way, it makes sense. It made sense for us to say, look, we're pretty comfortable with our two outdoor air sensors 6 miles apart as they are, and we seem to our pattern of savings seem that to which that is an input point is significant, is important. So this felt to us, and I guess I'm paraphrasing for you, David, that it's a lot of additional cost for not a lot for a proportional benefit. Am I putting words in your mouth?
No, that's correct. In fact, in some cases, it's a lot of additional money and a diminishing of the ability of us to get an accurate reading for starting chillers and so forth. So,
yeah,
it
okay.
actually does more harm than good. Even if it wasn't, even if it was a no-cost item, we wouldn't want to do that.
Okay, you want to run ahead to your second one then, Dave, and that'll probably be, it's the one having to do with labor. Oh, yeah, right. I will have this. I'll do a recap, and I have this all reproduced.
Okay. Let's see. The next thing on here. Some of these things you see in yellow are just typographical. I'm not going to go over those.
I thought the one about burning in contract labor was important.
Yes, that's the one I'm going to get down to here. It's quite a bit further down the line here.
So while he does that, Kathleen, do you have any questions?
I was going to comment that when I read that paragraph that we were just talking about, I did sort of agree that one in every building could be a real cost prohibitive. But I was thinking that the standard should somehow be written that there is some redundancy or have some kind of backup plan set into it so that if the network goes down or if the single sensor that serves the whole campus would go out, that there would be something else reliable and that would work under kind of the same logical sequence to let the buildings operate, so that you wouldn't have to have people default into just on or default into time or something like that. That way people could still maintain their high energy efficiency that they could get from having the outdoor air sensor, but they'd at least have a backup.
Yeah, we do think a backup is important. We do have backup sensing. Where we wouldn't be able to use that backup sensing is if there was something wrong in the network that would prevent us from sharing our main master. It would also potentially keep us from sharing our backup. So our plan, our backup to the backup, so to speak, is that if we're in a situation where we lose communications and can't share that information, and we have chiller systems that are relying on that, we will still check to see when it's getting close to the time or when the temperature is getting to the point where we need to make that switch, and we have people that can go make it at the building level itself, and just basically manually commanding those points so that the chiller will be in the right mode. So we're not talking about information that changes very often, very rapidly. Exception maybe when a thunderstorm rolls through, you get a sudden drop in temperature, but generally there's time to be able to get out and make these kinds of changes as needed.
There you go. I think you just passed it.
No, that was another typo thing. Sorry that it takes. There's like this thing's in the corner of the screen here, and I couldn't grab my scroll thing. Now I can finally get to it. It's down below.
So as you can see, it's a Friday afternoon in August in academia. There's a few students here. We're by little, we're starting to fill up. The town feels that way after having been here for 30-odd years. the mood of every week is very distinct. I actually went to school in Boston, Kathleen, at Cambridge actually. Where's your office located there?
The office used to be in Cambridge for a long time, but now it's in Charlestown, right by Sullivan Square.
Oh, yeah.
It's on the water. It's on a street called Medford. I forget I think Sullivan Square is the closest T-stop.
Medford, yeah.
Yeah, exactly, Medford.
It doesn't sound like you're from you're from Boston, though, based on, although sometimes I'm surprised. Are you from other parts of the country?
No, I'm from Cleveland. I split my time, actually, the company's based in Boston, but I split my time between our Cleveland office and our Washington, D.C. office.
Oh, okay. So you have your Cleveland, Washington, D.C., and Boston?
Yeah, there's 20. The other, we have I think 8 or 9 in California, Tucson, Phoenix, Kansas City. We have New Jersey. We have New York City, Portland, all kinds of places. There's one there's one in Detroit. It used to be in Ann Arbor, but I'm not sure if it's still there or not.
Mm-hmm.
I haven't been to that office or worked with people in that office, but we do have an office there.
Okay, then. Thanks for that. Let's see, Dave. You want to charge into this now?
Yeah. The other one that we thought was substantial was where they refer to software being programmed by either the manufacturer or by a systems integrator. But in our case, the third option is by in-house technicians, and in a lot of cases this statement would be true, but in our case it isn't, and we certainly don't want it to get written anywhere eventually into specifications that it must be done by either the manufacturer or a systems integrator, and not allow or not have our in-house technicians being included as one of the possibilities. What we do is we carve out the proprietary part of the project with building automation, so we'll buy the Siemens field hardware, but we will competitively bid all the engineering, the startup, the checkout. Well, some parts of that is done outside, parts of it are done in-house, but we'll competitively bid out the wire, sensor, conduit installations, and just that component that you could consider to be proprietary. Then we come along and complete the job with programming that at the end with in-house technicians. And that allows us, even within a building that's already been built, to still get competitive bidding on future additions and retrofits and so forth. So we wanted to protect that ability here. If someone sometime would maybe interpret this as saying, oh no, you can't do this yourself.
Yeah, there's a number of those documents that actually do burn in labor, and very often local government, state, and local agencies are complicit in that. So we wanted to, quote, nip this one in the bud. We are coming onto a time limit here, Dave and Kathleen. What I'd like to do here then in the last few minutes is, Dave, I'll take the screen again and I'll do a summary statement of the position that was entered and try to explain to Kathleen and others who will be watching this clip why it's important to follow this. Do you mind, Dave? I'll be taking over the screen.
Yeah, go ahead. Take it away. I'm all set.
Okay, and then finally, then let's talk a little bit about what you got done here at Ross, and we can get over, and that will be within the next 5 to 6 minutes. So, all right, let's take that over now. This will be, I'm the presenter again, and I have a statement here that I try to point out. Okay, so in what I do, Kathleen, I'm not sure how familiar you are with our, with what U of M has done over the past several years. We have a website that tries to explain. We essentially founded what I'll call the assertive regulatory capability of the education facility industry. So here's me, my boss, and I'm not sure if you're familiar with them, but we actually have we have the main vote, and I have harvested other votes for APA, but in general, it's fair to say that we are the first mover in this space. So that much said, the reason we follow this is, and the reason we try to be very orthodox in how we count our avoided cost. Unlike avoiding CO2 sensors and additional outdoor air sensors, we know what they would cost if we had to buy them, but we also have to try to be as orthodox as we can about what avoided regulatory burden is. So on our website, you'll see what we believe our best bit of due diligence and our best guess. It's more than a guess, actually. We feel that we're awfully close, within 10 to 20% of these numbers. So we took a $50 million building and we try to project what standards advocacy has resulted for the entire industry. And we believe that we can take about $1.5 million off of a 50 million building, and in addition we can reduce the O&M burden. Now we're not including this recent statement to the ASHRAE 13 committee because it's not a done deal yet. However, there are others that have. So in a certain sense, we're continually revising this and trying to make sure our numbers are orthodox, but to some degree we have to take a guess. We have to take a guess. We can't really guess at what safety is. We know that we've avoided risk, but it's very hard to count something that doesn't happen. So we just let that be part of our safety margin, so we don't overstate our savings or value add, or we don't understate our value add. So along those lines then, what I try to make people understand is that, you know, me having done this for 17 out of the past 33 years I've devoted to just this, is that this is market making by incumbents. Dave will talk a little bit about CO2 sensors as we close this conference. We'll talk about CO2 sensors in this building specifically and what they do and how outdoor air sensors would help or would not help. So what we're trying I'm restating and I'm taking Dave's statements and putting them in what's going to amount to a PowerPoint presentation, which will show. These are your two. I've just taken these and put them in what I'll call PowerPoint or Prezi format. So we use this as an example of how the regulatory processes are used to make markets for manufacturers, and that's what this is. They know it, we know it, and that's how the game's played. So it'll start out as a guideline, right? It'll be a statement and a guideline. We have 30 days to respond to it, but there's a process in ASHRAE 90.1. As you can see, this is actually ASHRAE 90.1, where you can adopt by reference. Everything that appeared in the guideline now is part of ASHRAE 90.1. Everything that was in the guideline is now in ASHRAE 90.1. And oh, by the way, what is in the guideline? Well, nobody saw that because you're going to have to pay for that. But there wasn't a large review among a balance of stakeholders. And once it's in ASHRAE 90.1, given that it tends to be the gold standard for energy conservation, it is adopted directly into the Energy Conservation Code. So very quickly, you can, within, let's say 3 months, go from a statement that's in a guideline, and very shortly it gets incorporated into the standard, and now it becomes enforceable code. So that's my statement about why we do this. This happens on more or less on a weekly basis. We have issues coming at us more or less hourly, but this is a case where we see market making, and I think what we'll do then is we'll let Dave make some final statements about how we actually successfully down here, what did we do, mechanical? Yeah, right here, demand control ventilation. They were trying to make markets for their increased numbers of CO2 sensors in buildings. So, Dave, can you give us a quick thumbnail? I'm going to give. This is the whole building now. I'm going to turn. Say something a bit about what you can about what you got done here at the Ross School. I'll try to give a picture of it while you talk about it. Talk specifically about the carbon dioxide sensors and how you use new regimes here to control building and energy usage. Go ahead, Dave.
Sure. Well, In areas where you have large assemblies, CO2 sensors make sense. They can tell you when you have 1,000 people in a room versus only 200 people in a room, and you can change, of course, your ventilation rate accordingly. But they wanted to start putting them in every single room, and what we found is in a small room, when you occupy that space, if you have enough people in there to change the CO2 level, you've also generally changed the air change rate because of temperature control needs. So CO2 sensor really wasn't providing any value to us. That's fortunately been successfully taken out of one of the requirements for projects such as the Ross School of Business. In the Ross School of Business is one of the buildings where we're doing continuous commissioning, where we're doing data-intensive views of everything going on in that building and being able to capture areas that are potentially wasting energy, yet not to a degree that would generate some kind of an alarm. So we're looking at the kind of the higher hanging fruit, as they would say, to get an additional squeeze 3 to 5%, maybe more energy reduction out of these facilities that already have quite a bit of equipment in it to help reduce energy. So that's kind of the quick, short snapshot of what we're doing over at Ross.
Okay. That's, by the way, I just took a picture. That's our new president, by the way. As he was coming by, he said hello. So anyway, Kathleen, this is the atrium where we're at right now. This is what's actually happening. Just to recap then, to get this call over with, the ASHRAE 189 committee, you're happy to call me if you want a specific reference to it. I can show you what we did on it, and we can show you the transactions. They basically wanted to double the number of CO2 sensors in classrooms. They basically wanted to double the number of CO2 sensors in classrooms. So we managed to, without any data, they were actually asserting that without any data to support it. And of course we said no without any data to support it. So that's how the game is played. And it's happening hourly, and it never stops. We've got one that came up on plumbing fixtures here I have to deal with pretty soon. So that's kind of our story, Kathleen. Is there anything else? I appreciate your coming here. I hope you can show the YouTube clip. It'll be up probably later on tonight or tomorrow. Anything else we can help you with, Kathleen?
No, that's good. I was just going to say, to reiterate, when I fly from here to Washington, which I do very regularly, I more than once or twice a year meet somebody who manufactures a widget and is off to ANSI to try to get approval or to somehow pitch how their thing should somehow be included in the standards. So I've seen it live in action. I've heard people talk about how they want to go do it without quite calling it what you're saying, but it happens. I've definitely seen it.
Yeah, it's very touchy because most of the trade associations depend upon the revenue that's generated from selling those products.
Right, and there is a other side of the coin, which is, of course, that some of these things are new and innovative, and people won't even consider them unless ANSI says it's worthwhile trying out. There's a point at which you need to somehow get ANSI to say yes, so you'll have legitimacy, and then there's another tipping point to the idea of you're trying to do more market building. That's right.
Yeah, I like to say that the public sector does need a healthy private sector. We need their innovation. Very often they're able to bid away some of the better talent, with better salaries and benefits and such. So they have that benefit. On the other hand, the private sector can't go overboard with some of the costs because the public sector is shared by all. And so there's a kind of a yin-yang relationship there that we have to be mindful of, a delicate balance. So we both need each other, but when we think that there's excess, we have to let them know about it. And certainly that was the case with this one, and I do respect opposing points of view on that. And I'm eager to hear the point of view. So, well, look, Kathleen and David, I'm very grateful for your time. I hope this helps our viewers, and let me know how I can return the favor. apart from that, I just want to hope you have a great weekend, and I'll see you on the Worldwide Inner Tubes. Bye-bye.
Sounds good. Thank you. Bye-bye.
Thanks, Dave.
Sounds great. Thanks.